Welcome to the DIY Honda Garage channel. The Honda CRV from 2017 to 2022 may encounter a diagnostic trouble code DTC P24B8, which refers to the EVAP Evaporative Emission Control System leak check module's absolute pressure sensor being out of range. This DTC indicates that the engine control unit, ECU, has detected an anomalous reading from the pressure sensor. The absolute pressure sensor's role is critical in monitoring the pressure within the EVAP system, which helps ensure that fuel vapor is contained and managed properly to reduce emissions. If this sensor malfunctions, it can trigger several problems related to the emissions system. The error is confirmed through the Onboard Diagnostics 2 OBD-II system when certain operational thresholds are not met. This code is often active during vehicle operation, but may also be pending. Thus, understanding the system's components and readings is vital for appropriate troubleshooting. The EVAP leak check module plays a key role in managing fuel evaporation from the gas tank, fuel lines, and vapor canister. Specifically, DTC P24B8 captures issues where the absolute pressure sensor in this module cannot provide accurate readings. This sensor is typically located on the EVAP system, which is integrated within or close to the fuel tank. Its primary responsibility is to monitor the pressure changes in the EVAP system to detect leaks or failures. When there are discrepancies in the readings, it can indicate either a fault in the sensor itself or potential wiring issues that interfere with its operation. Correctly diagnosing this DTC eliminates potential causes or failures that could lead to reduced vehicle performance, increased emissions, or even a failed emission inspection. Several potential causes could lead to DTC P24B8 being triggered in your Honda CRV. Firstly, wiring issues such as frayed or broken wires can disrupt the signals from the absolute pressure sensor to the ECM, engine control module. It's essential to conduct a thorough visual inspection of the wiring harness connected to the EVAP leak check module. Secondly, the EVAP leak check module itself may also be faulty or experiencing internal issues that hinder its performance. Lastly, the sensor may be malfunctioning due to wear, dirt, or internal failure, which is a common source of such error codes. As a technician, it's crucial to systematically check each of these components to determine where the fault lies. When encountering DTC P24B8, several symptoms may manifest in your Honda CRV. The most noticeable indicator is a check engine light on the dashboard, alerting the driver of an issue that needs attention. Drivers may also experience performance-related issues such as reduced engine efficiency, rough idling, or hesitation during acceleration. These performance dips are largely due to the engine control unit trying to compensate for the inaccurate readings from the faulty pressure sensor. Furthermore, higher emissions may occur as the EVAP system is unable to monitor and control fuel vapors effectively. If these symptoms are present, immediate attention is necessary to avoid further complications. To initiate troubleshooting for DTC P24B8, begin by putting the vehicle in the on mode. This means the ignition should be turned on without starting the engine, allowing various systems to power up. Use the Honda Diagnostics System, HDS, to clear any existing DTCs. Once cleared, switch from the on to the off mode and then back to on. After this, check the absolute pressure of the ELCM, Evaporative Leak Check Module, pressure sensor using the HDS. This step serves to verify if the sensor readings are within acceptable limits or if they exceed the set threshold, helping to identify if the DTC is indeed relevant. As part of the verification process, check for any additional pending or confirmed DTCs using the HDS. It's crucial to identify if DTC P24B8 is specifically indicated. If so, this confirms that the issue is duplicated as per the first step and should be addressed next. However, if the DTC is not present, it may point towards an intermittent failure. In such cases, inspect the wiring and connections to the EVAP leak check module and the powertrain control module (PCM) for loose or poor connections. This visual inspection can unearth hidden issues that may not be easily visible through electronic diagnostics. For Step 3, ensure to turn the vehicle to the off or lock mode before conducting further tests. Proceed by disconnecting the 8P connector from the EVAP leak check module. With the connector removed, turn the ignition back to the on mode while keeping the EVAP module disconnected. Measure the voltage across the designated test points as defined in the diagnostic process. Specifically check between test point 1 and test point 2. If the voltage is about 5.0 volts, it confirms that the circuit's integrity is intact up to this point. If not, you will need to take further steps to troubleshoot. Move on to Step 4 by examining the absolute pressure readings of the ELCM pressure sensor using HDS. This time, look for values below the threshold of 331 millimeters per minute. If the pressure readings are indeed less than this value, it indicates a potential issue with the module's ability to sense pressure accurately. By confirming whether the pressure conditions match the malfunction threshold, you'll establish if further steps are required, or if you should loop back and consider replacing components. Awareness of these readings is key in guiding your next troubleshooting actions. Step 5 involves simulating operation by connecting two terminals in the EVAP leak check module 8P connector, specifically terminals A and B. After jumping the terminals, turn your vehicle's ignition to the on position. Following this, you will once again check the absolute pressure values of the ELCM pressure sensor via the HDS, aiming for more than 896 millimeters per second. If the reading meets expectations, it suggests that the sensor is correctly functioning, and the module itself is likely in good condition. Conversely, if the reading fails to meet this value, replacing the EVAP leak check module might be the next necessary action. As you progress to Step 6, focus on the VCC6 line, which supplies voltage to the EVAP leak check module. First, ensure that the vehicle is turned off. Afterward, utilize the HDS to jump the SCS, service check switch line, and wait at least 1 minute. Disconnect the PCM connector labeled E80P, and now you will need to measure the resistance between two specific test points. This resistance check must occur leading to values of 1.0 ohm or less. If it exceeds that, it can indicate an open circuit, meaning the VCC6 wire might be compromised. In this case, further repairs to the wiring are necessary to restore normal functionality. Step 7 focuses on the SG6 line, another vital component leading from the PCM to the EVAP leak check module. Similar to earlier steps, confirm that your vehicle is in the off mode before proceeding. Measure the resistance between the PCM connector E80P and the EVAP leak check module's 8P connector. The goal is to ensure that the resistance is 1.0 ohms or less. If the reading is acceptable, this suggests that the SG6 wire is operational and not responsible for triggering the DTC. However, if it doesn't meet the defined threshold, this indicates an open circuit, necessitating repairs to that specific wire for proper system functionality. In Step 8, attention shifts to the ELCM-PA line, where the focus is on the wiring and its integrity. Start by switching your vehicle to the off mode before disconnecting the PCM connector A. After this connection is made, you'll measure the resistance between the EVAP leak check module's terminal 7 and a body ground. You aim for a resistance reading of 1 megaohm or more. If the resistance is adequate, it confirms that the wiring connecting the PCM to the module is in good shape. If the reading fails, it points to a short within the ELCNPA wire that needs addressing. For step 9, you'll begin by removing any jumper wires that you have set in previous tests on the 8P connector of the EVAP leak check module. With the system still in off mode, initiate a fresh measurement of resistance between specific test points. In this instance, you'll check the resistance between PCM connector A terminal 42 and the EVAP leak check module's terminal 7. Again, your target is a reading of 1.0 ohms or less. This step serves as a validation check for the ELCMPA wiring. Should the reading not meet this standard, it indicates an open circuit requiring repair to ensure that proper signals can travel between critical components. After completing troubleshooting for DTC P24B8, it's essential to perform a final verification of your repairs. Start by clearing any diagnostic trouble codes from the vehicle system using the Honda Diagnostic System. This allows you to reset the system and eliminate any previously stored codes. Monitor system performance after the repairs. Ensure the engine runs smoothly without triggering the check engine light. Additionally, it's crucial to check for recurring issues by conducting a road test to ensure that the EVAP system operates as intended. If no new fault codes arise during this period, it can be safely concluded that the issue has been resolved effectively. Preventive maintenance is vital to avoiding future occurrences of DTC P24B8. Regular inspections of the EVAP system should be conducted to ensure all components are securely connected and free from wear or damage. Maintaining the health of the wiring associated with the EVAP leak check module should not be overlooked. Consider using protective sheathing or routing strategies to minimize potential wear. Additionally, keeping the EVAP components clean from dirt and debris will assist in long-term functionality. Setting maintenance intervals for checking these areas can greatly improve vehicle reliability and prevent costly repairs down the line. In conclusion, comprehensively understanding DTC P24B8 and its implications is essential for effective vehicle maintenance and repair. Following a structured troubleshooting process allows technicians to pinpoint issues with accuracy and efficiency. From initial diagnostics through to final verification, each step plays a crucial role in not only correcting problems, but also enhancing the overall reliability of the vehicle. Moreover, by prioritizing preventive measures such as regular inspections and maintenance, you can ensure the longevity and optimal performance of your Honda CRV. With diligence in repairs and maintenance, ongoing issues can become a thing of the past. Please like and subscribe to the channel. See you next time.